So good morning, everybody. Welcome. My name is Pim van Baarsden. I'm CEO of the Silverson Technology Cluster. We're a not-for-profit cluster support organization here to assist all the advanced engineering, electronics, and software businesses in the wider Silverstone area. Our webinar today is done in conjunction with the Open University. They've put together a very tight schedule for you, which should be really interesting. But before we kick off with that, I just want to give a brief acknowledgement to our supporter for our webinar series, which is Hexagon. Hexagon is a global leader in digital reality solutions, combining sensor software and autonomous technologies. Hexagon Manufacturing Intelligence Divisions provide solutions that use data from design and engineering, production, and metrology to make manufacturing smarter. To find out more about what they do, visit their website, hexagonmi.com. That's Hexagon with the M for manufacturing and I for intelligence.com. So please have a look at what they do, and we thank them very much for their support with this series. But with that, I'm going to hand over to Jason. Just a couple of housekeeping things. We'll do a question and answer session at the end of the session. So please hold your questions until then, or indeed put your questions in the chat, and then we can take it off. We can tackle them there. But Jason, over to you, I think.
Okay, thank you very much, Pim. Go to the next slide, Julia. And the next. Excellent. So thank you for joining the webinar today. I apologize I've not got my webcam on, but I'm having a few technical problems. So my name is Jason Baverstock, and I work in the Research and Enterprise Office at the Open University. And two of my colleagues, Julia Freer and Denise Pasquet, are joining the webinar today. And it's Julia that's done most of the work putting it together. So we've got a lot to fit into a relatively short amount of time. Before I start, I thought it'd be good to give you a bit of a short introduction to the Open University, just to give a little bit of a background on who we are and what we do. Go to the next slide, please, Julia. So I imagine everyone's heard of the Open University, and we've got a global reputation as a leader in online learning. And we were established in 1969, and since then we've taught over 2 million students. And so by student number, the OU is the largest university in the country, and we've got offices in all 4 nations, and that kind of makes us unique amongst UK universities. And this reputation for online learning is great, but as our teaching brand is so strong, what a lot of people don't realise is there's a lot of research going on at the OU. And we've been to various meetings, and people have said to us in surprise, oh, do you do research at the OU? I didn't know that. So what I'm going to do now is just spend a couple of minutes just introducing you to some of the research you do, just a very broad overview. Go to the next slide, please, Julia. So this picture here shows our Walton Hall campus, and this is in Milton Keynes. And this campus has over 4,000 academic, research and support staff all working on it. But in addition to these 4,000 people, the OU's got 6,000 associate lecturers. So these are people based all over the country that support the students. But we've also got over 1,000 postgraduate students, and that includes around 300 PhD students. So all in all, we are a very large organisation, and we have a physical campus in Milton Keynes. Again, something not an awful lot of people know about. So as far as research goes, the OU's total expenditure on research development is around 50 million a year. So if you put that in the grand scheme of all the universities in the country, we're kind of like a mid-intensive university when it comes to the amount of research that we do. Have the next slide, please, Julia. Okay, so the research at the OU split into 4 main faculties. This is the STEM faculty, the Faculty of Arts and Social Sciences, the Faculty of Business and Law, and the Faculty of Wellbeing, Education and Language Studies. And although these are discrete faculties, as a university, we try to take a cross-disciplinary approach to solving challenges. And the value of this was really demonstrated during the recent pandemic, where I'm sure you're aware an awful lot of challenges were solved by both technical and social solutions. So whilst for technical-based challenges, it is natural to look for solutions in STEM disciplines. There are also solutions or collaborations have elsewhere. An example of this is in our Faculty of Business and Law. And recently they've been doing projects on solutions for smart cities or mass implementation for electric vehicles. It's similar also in our Faculty of Arts and Social Sciences. And there's an awful lot of work addressing society's most pressing challenges. but that's engaging both scientists and social scientists, especially when considering efficiencies or implementation strategies. The next slide, please, Julia. But as a scientist, well, I should say a former scientist, I'm always most closely drawn to the sciences. And at the Open University, the OU has got the Faculty of STEM, and this comprises 6 schools. And so this covers computing, communications, engineering and innovation, life, health and chemical sciences, maths and statistics, the environment and physical sciences. And so they cover a huge amount of different types of science and technology. You might have heard of some of the research that's come out of the STEM faculty. One of the main ones that a lot of people know about is from the School of Physical Sciences. And these have contributed to many space missions, probably the most famous being the Rosetta mission, where they landed on a comet. And what the OU did was develop the instrumentation that was on the lander, which surfaced the volatiles on the surface of the comet. A second example is the OU material engineers, and these led a research consortium that built Engine X, which some of you might be aware was the world's first neutron diffractor. It was optimized for stress testing. And we're going to be hearing a bit more about stress testing a bit later on from Jefferson. A more local example we might have come across, more recent, was the MK Smart project. And this was a £20 million project that the OU were partners on, which helped develop Milton Keynes as a model smart city. So I appreciate this was a very, very broad introduction to research at the OU. But what I hope it's done is just kind of make you aware that there's a whole lot more to the Open University than distance education alone. And so as time is pressing, I think it's now time to move on to our first speakers. And this is Paul Aldridge from WJ Products and James Bruce and Denise Pasquet, both from the OU. And they're going to talk about a recent knowledge transfer partnership that they did and the benefits it had for both the business and the university. So over to you, Denise, Paul and James.
Thanks, Jason. My name's James Bruce. I'm a chemist at the Open University, and a lot of my research is focused on designing functional materials, by which I mean we control their properties in terms of their use of sensors, how we can use them and remove them, and control their properties with a tighter degree of precision than normal. One of the challenges I have as a research chemist is then taking what I'm doing in the bench in the lab out into the real world. And so I do a lot of engagement with industry. And if you go to the next slide, please. One of the ways I've been doing that is through a knowledge transfer partnership. Briefly, that's a sort of a moderated collaboration between university and industry. It's funded by Innovate UK, and it brings together industry and university partners around a common problem. It employs a particular researcher known as a KTP associate, and alongside their developing their sort of science skills, they develop business skills as well, which I think again is quite useful at that university industry interface. I think what industry gets out of it is that they get access to the sort of fundamental R&D expertise and the facilities that exist in universities. But I really want to stress that this is not a one-way process. As an academic, I get a means of translating my research out into real-world problems, which is actually a really interesting challenge to solve. And so in this particular case, I want to talk about a partnership we had with WJ Group that's been going for at least 8 to 10 years. And so if we could have the next slide, please. This began with a knowledge transfer partnership, and a key part of it was to understand and develop new materials that the WJ Group could use in their road marking applications. And I'll leave Paul to just to talk about the implications from the WJ perspective. For me as a chemist, it was working together with them to understand how we could test ideas and applications, and in particular, use the kind of facilities that we had at the OU, and some examples here of the sort of instrumentation that I can deploy that allow me to analyze the sort of materials we're making or the materials that are currently in use, understand the properties and that currently exist, and understand the impact that the sort of chemistry research that we're doing has on improving and enhancing and controlling those properties. So just going from left to right, we've got an NMR spectrometer, we've got infrared, and we've got fluorescence. So a lot of my materials are what I call photoactive. They respond to light, and so they're quite useful in a wide range of applications. So we can have the next slide, please. Again, stressing this, the key thing was a collaboration right from the start, and this was where I think KTP is particularly useful because it is moderated. We sit down with WJ and we were talking about the objectives and what we were both hoping to get out of it. It's a very sort of open and honest, this is what we're trying to do and this is what we'd like to achieve. And so we agreed a set of sort of protocols that were common to both, that we could have an efficient mutual research and development process. So it's not like me sitting in isolation in my lab, coming up with a result, taking it to them, and then finding it doesn't work. So they had a lot of input into how we designed the initial set of research experiments. And so the advantage we brought with our sort of research infrastructure is that we can test and screen all sorts of combinations in terms of trying to make different new materials and deciding whether or not they will work. And then we link that to WJ has a quality assurance, quality control set of labs and analytical tests, and they can use those to help us screen anything that we're producing in the OU labs that will fail criteria for road marking in terms of how well they cure, their hardness, whether they reflect car headlights appropriately. And in that respect, we will reject materials, even if the chemistry that I've designed is right and scientifically and academically interesting for me, we don't progress it because it's not going to be of any benefit to the company. So it's quite important in this kind of relationship. But yes, I've got sort of academic interests, but I'm also being influenced by the needs of the of WJ to produce a material that is that's useful to them. So it throws in more interesting academic questions in terms of making materials that are cost effective and accessible for non-chemists to use outside the chemistry lab. So go to the next slide, please. And so where we've got with the KTP, it's successful in terms of building up a basic R&D collaboration between WJ and the OU, which still goes on to this day. And we're very much focused in helping with innovation in the terms of how they design new products for their that they can deploy in road marking and sort of traffic management situations. And so some of the sort of things we're looking at now are sort of cold applied materials, things that can be handled at sort of ambient temperatures rather than having to use high temperature melted materials. We'll look at trying to help them improve the process by which they can lay their road marking, with inherent sort of hopefully improving the safety of the users when working on the road. We're looking at water resistant materials so that they can lay markings in all sorts of road conditions. We're looking at light and other ways of curing and decuring the road materials, in a particular view of looking at how we can remove the material when it's at the end of its life. And we're currently really looking at looking at how we can reuse materials in a sort of closed loop and help the WJ group move on, address their sort of sustainability issues, and so that we're reducing the sort of the single use of materials and consumption there. So I hope that's a bit of a quick sort of walk through from an OU perspective, and I'll now hand over to Paul from the WJ group to give you their perspective from this partnership.
Hi everybody, can I have the next slide please? Excellent. So as James says, I'm Paul Aldridge. I am Group Sustainability Director for WJ, and I was chair of the KTP. We're quite an interesting industry in that it's very, very traditional. We're still using the same techniques and materials that we were using in the middle of the last century. Materials that were developed in the 1930s are still commonly used. So there's been little development of the materials and processes, and we've got this need now to develop sustainable materials. So we were looking for some advanced academic input into allowing us to access areas for expertise. It's quite interesting that we have our own chemists, but as with everything, it's looking outside is quite important, and we've constantly, our industry is very insular, so it was reaching out to get this academic input, which was really important to us. Can we have the next slide please? So we started the KTP, and it did produce some really promising results, as James said, particularly around light curing of materials. But one of the things that's really excited us is how it opened this channel of communication where we could actually get hold of people and talk to people about the issues that we were facing with our products, where we might look to develop new products. Obviously, it's a very competitive industry, so very much governed by price, but also more and more quality comes into it. I'll talk about that in a moment. Our KTP associate did very well out of it. So they went on and got a job with BASF and doing really well, still keeping contact. But it introduced our WJ and OU to work together through our innovation group as a company. Next slide, please. So beyond the KTP, we're starting to look at new ways of collaborating and it's looking to be very successful. We have a new project looking at temporary materials. What we're trying to do here is develop a closed circuit circularity, particularly for plastics. There's a lot of plastics used in our industry, and there's nothing inherently wrong with plastic as long as we can keep it within the same loop. And just looking at for incremental improvements at the moment, so we're looking at the fundamentals about how we lay materials, how we pick them up after use, and then how we can recycle them. And this has created properly good industrial partnership, and it's something that without the skills of the Open University we'd be struggling to do it on our own. So if we have the next slide, please. And there's a happy coincidence here. So as the countries come out of pandemic, social values increasingly important to us. So we've had things like the Public Services Social Value Act, which required government and local authorities to pay cognizance to social value in developing things. But recently, the government, as part of Build Back Better, produced something called Procurement Policy Note, taking into account social value. And one of the things here that you can do is measure your innovation. An innovation that's towards social or environmental improvements can be measured and used to give you an advantage in the public procurement process. So quality is an important measure, and we can measure this, the work we've done with the Open University here, and it's another angle that people haven't perhaps looked at in innovation, particularly for sustainable innovation, and how it can help industry. And we can measure this, what we're doing with the OU, and it will give us another advantage in gaining public contracts, and we make our living from the public purse. It's a really interesting angle. So thank you for that. It's a brief, really whistle-stop tour of the stuff that we've been doing, but it's been a great value to us as an organisation. Over to you, Denise, if you're there.
Thank you. Thanks, James and Paul. That really leads me nicely on to giving you a brief overview of what knowledge transfer partnerships are. Now, KTPs are a part UK government scheme to help companies innovate and grow. And they've been around for almost 50 years now, so it's been tried and tested. So if your business is looking for a low risk, cost-effective way of running a strategic project to create a return on your investment for your business, if you're looking for a talented, high caliber graduate who is employed by the Open University, so they're not on your books, working full-time on a dedicated project that can be from 1 to 3 years in duration, and half a day per week of high-level academic input to support your project, then a knowledge transfer partnership could be the solution. If your company's VAT registered, your business can claim back its contribution through its R&D tax credits. And if you're an SME, your company contributes just 33% of the cost of the KTP. as James said, the KTP associate acts as the conduit. They lead and project manage the strategic project, supervised by the OU academic and a company supervisor. Now, KTPs are a win-win-win for the company, for the academic and the university and the associate. I'd like also to take this opportunity to mention that Innovate UK are launching a new Act to Innovate mini KTP very soon. And this one, the Accelerated Knowledge Transfer to Innovate KTP, will be 12 to 16 weeks long. And projects will, again, use a recent graduate or somebody with a PhD, seconded to work with a pre-identified company. So this company could be you. For this mini KTP, the company only has to contribute 1.5K in cash. So it's a very low barrier to entry. And the projects are roughly around 35K in total. Now, the application process and the project management are supposed to be light touch. And I'm hoping to get more information about this in July, with possibly September for applications to go in. One of the good things about this Act to Innovate project is it won't preclude companies from engaging in a follow-on KTP, and they can be used to scope a KTP project. They're a great way for academics to get to know and understand the business, and for the businesses to learn about the Open University, our knowledge and expertise. And working together, hopefully they can solve problems and challenges. Next slide, please. Over to Amir.
Okay, thank you very much. Can you hear me now? Can you hear me?
Yes.
Okay, excellent. Hi, everybody. My name is Amir Shirzadi. My specialty is diffusion bonding, is a kind of unconventional welding or joining method, which is used in very specific applications, and more recently on manufacturing laminated objects, which I will mention shortly. Next slide, please. Okay, Open University is, to the best of my knowledge, is the only university in the UK equipped with the diffusion bonding facility. We have several rigs, and the process of diffusion bonding basically is welding materials or joining them well below their melting point in order to maintain their original properties. I have done many projects in various companies around the world, which you will see in the next slide, please. These are the companies which I conducted R&D projects for them. The size of the logo, it relates to the size of the project, not the company. And as you see, that it's quite a renowned company which I worked with them. The projects were either a feasibility study to see the possibility of finding a solution for certain problems. Some of them, they went up to the prototyping level, which we basically prototype the component and send it for the testing. And in few cases, we ended up with manufacturing the actual full-size component for the company, which you will see some examples later. As you see, there's a variety of all sorts of company, electronics, vacuum, Red Bull Technology, and other oil and gas companies around the world. Next slide, please. Yes, it is a typical example, just the start of the pandemic, when the demand for production of the vaccine went up. The vaccines manufacturers, the component which makes vaccine, all of them, they're sterilized using a very high intensity X-ray sterilizer, X-ray based sterilizer, which are mostly made in the United States. A key component for the vaccine sterilizer is a component which is made of steel and aluminum. It has to be welded. The only technology existed in the world was by explosive welding. But American company couldn't basically keep up with the demand. Explosive welding has a very long leading time, up to 1 year, and low reliability. So they asked us to replace the explosive welding with the diffusion bonding. And during the campus lockdown, I and some of my colleagues, we were working around the clock to replace them. So within a few months, we developed a new technology. Then we moved on even to manufacturing the actual real size component, which were sent to United States for assembly and testing. The latest news 2 weeks ago, all the components we've sent been installed, and not even one is failed so far. So this is the world first diffusion bonded bimetal component for the vaccine sterilizer. Next slide, please. These are the other examples of diffusion bonding. Top left, two completely unweldable material can be joined by diffusion bonding. Now I have a project on aluminum to sapphire, which has application in the fusion reactors. I have a mini project. On the top right, you see components which are actually weldable, but you're looking at much higher precision and so on. On the bottom, it's about laminated object manufacturing, which I will explain a little bit more later. But on the right-hand side, you see example, extremely high precision component, which was basically a turbine for the satellite with 250,000 RPM, which I manufacture the actual component and send it to the UK manufacturer of the satellite components. Next slide, please. Okay, these are the other examples. On the top left, it's a high precision joining of steel. You don't see any fillet or the undercut, or a special bellows, which are non-magnetic. And on the bottom right, bottom left, you can see a component which I made by buying a 10 pounds aluminum powder from eBay. It's made by sintering and diffusion bonding. Next slide, please. Okay, this is the hot topic. And actually, at the moment, I am sitting in a hotel in Germany, East Germany, because I am here to manufacture components similar what you see here. These are the laminated heat exchangers, which the top right and the bottom one made in the UK, in the Open University. But at the moment in Germany, I'm manufacturing much larger one because there are larger machines here. And these are laminated objects. So they make extremely compact, efficient heat exchangers for jet engines and oil and gas. Next slide. And this is a last example of, it's just not related to bonding. I also done lots of development on manufacturing new processes. This one's just an example on a process called melt spinning, not to be confused by metal spinning. Melt spinning, we inject the molten metal on the rotating copper wheel to make a ribbon. It solidifies in a fraction of a second and forms a ribbon. My contribution was that I basically invent technique, which is auto ejection. The machine ejects the molten metal without any expertise or any skilled operator. And this led to the world first auto ejection melt spinning, which is made in Germany. Thank you very much for your attention. If you have any joining problem or any looking for a new manufacturing process, you know who to contact. Thank you.
Thank you, Amir. That was great. So now we're moving on to Jefferson, who's going to talk to us about StressMap.
Hi, good morning, everyone. My name is Jefferson, and I'm the manager for StressMap. StressMap is a residual stress measurement consultancy, part of the materials engineering group here in the STEM faculty at the OU. Next slide, please. So we've been founded in 2013 to cater for the need from industry to map residual stresses across large components. And we specialized in the contour method. We've been doing it since 2001, 2002. And it's a very powerful method where you can map the residual stresses inside the part from the manufacturing process across the entire cross section. Next slide, please. So this technique can be applied to. Is it missing something here on the top left? Can you go to the next one, please? Is it? Oh, there you go. Yeah. So it can be applied to small or large components, and it can be you can actually measure the multiple stress components by combining the different techniques that we have here in house. So we can offer the contour method, and as a supplement, or maybe on its own as well, we can do X-ray diffraction or hole drilling. And we have a close collaboration with with STFC on the neutron diffractometer. Like Jason mentioned before, we had a key role in developing the instrument over there. So we've measured samples from 3 millimeter diameter all the way to 2 meters diameter, as you can see on the bottom there, and we can measure very complex shapes. And we work on a consultancy kind of contract, so paid by small projects, and we have a very quick turnaround because of that. We're basically set up to cater for industrial needs. Okay, I think that's it. Can you go to next slide? Oh, okay. So I just presenting here the facilities that we have in-house to process the data and to do the measurements. So we have a large EDM machine to cater for samples up to 550 millimeter long. And we have a CMM to measure the cut surfaces. And we also have a XRD measurement capabilities in-house. We have 2 different XRD diffractometers. And we also have a micro EDM machine to measure very small samples, like the 3 millimeter diameter rod that I showed in the slide before. And to measure the surfaces and to calculate the stresses, we use a confocal 3D microscope. And we also have X-ray hole drilling facilities in-house. I think that's the last slide, so over to someone else. Can you go to, yeah, over to Igor. Thank you very much.
So we'll now move on to Igor, who's going to talk about the electron microscopy suite.
Hello, everyone. Can you hear me?
Yeah.
Thank you, Jason. Good morning. My name is Igor Kraev. I'm a manager of electron microscopy suite here at the Open University. Next slide, please. Our facility currently has 3 transmission electron microscopes, 2 cross-beam systems, and 3 scanning electron microscopes, and a range of ancillary equipment for sample prep. We provide modern facilities for advanced materials imaging and characterization. And here I'm showing some examples of our work. Top row shows SEM images of different materials. Top left, failure analysis in thermal barrier coating, top center, carbon filter, low MAC carbon filter image, and top right, high resolution, high magnification image of lithium ion cathode active material. So we can deal with a wide range of materials, preparing them and image them for different purposes. Apart from just imaging, we can prepare samples for further analysis. Having cross-beam systems allow us to do that. Bottom row shows examples of what we can do. We can prepare a cross-section to measure coating thickness. Bottom left shows cross-section of graphene coating on molybdenum substrate. Coating thickness can be from tenths of nanometers to 100 microns. We can prepare TEM lamella of your sample, which can be imaged further in transmission electron microscope. So we can prepare TEM lamella from specific location. Here I show example of pure copper, of TEM lamella from pure copper sample. And the last technique, quite tricky one, we can prepare atom probe tips, which can be used further for atom probe tomography. Here is example of APT from apatite mineral, tricky sample charging. However, we managed to do that. We could do that on any material, but mostly metals would be used for this technique. Next slide, please. EM facility is also equipped with the latest analytical detectors to meet your needs. We have conventional and high resolution EDS and very fast EBSD detectors. Top row shows examples of EBSD analysis. Top left, creep cavitation on pure copper, which was which went through 100 hours of creep on our glass sample. Top center image shows fine-grained nickel superalloy, very high resolution EBSD map. Takes about a day or something like that. But we can see very small grains on the material. Top right image shows nitinol, which was bonded to steel using laser bed fusion method. We prepare this sample and analyze with EBSD further. Bottom row shows EDS analysis. Bottom left image, simple elemental analysis of titanium nitride particles. Bottom center image, chromium agglomeration of grain on of grain boundaries in steel or from valve sample project with our external client. And the bottom right image shows titanium coating bonded to stainless steel, showing the diffusion of titanium and iron in each other. The project with AMIA. I think I showed you a few examples of what we can do to move forward your work. Please feel free to contact me to know more about what else we have on offer and discuss in detail how we can help you. Thank you.
Okay, thank you, Igor. That was great. So that was 3 relatively short little talks on some of the capabilities and expertise we've got at the OU. So now Denise is just going to talk a bit about how you engage with the OU. What are the opportunities there and how do you do it? Over to you, Denise.
Thank you, Jason. Julia, Jason, Tony and I make up the central enterprise team within the Open University, and we are your single point of contact into the OU. And our aim is really to make your experience of the Open University a good one. Our email address is shown on this slide. As Jason mentioned, companies can engage with us through a variety of ways. So earlier in this presentation, James and Paul gave an example of a knowledge transfer partnership we had with the WJ Group as one way to engage with the OU. The OU has a wealth of knowledge and expertise to apply in practice to help you solve a number of issues and potentially help you leapfrog your competition and give you a competitive advantage. Companies can engage with us through a variety of ways. That could include academic consultancy, contract research, using our labs and facilities, using our experts to make sense of the results, and through funding schemes such as those I've mentioned, Innovate UK, and also other UKRI schemes. We can help you identify the best way to engage with us and the most appropriate funding schemes available at that time, and help match you with the academics who can solve your problems and issues. But the onus really is on you to take the first step, which is really to get in touch with us and talk to us. So feel free to come and talk to us. We're open, as our name suggests. So whether you only need access to our facilities and experts to interpret results of tests you undergo, or you really want to tackle a strategic issue, we'll make sure that we can do our best to help you deliver and put you in touch with the right people. I think that's really all I need to say at the moment, but we're here to help and we're open. So thank you very much for listening, everyone. And thanks, Julia, for putting all the slides together.
Thanks, Denise. So yeah, I think I'll move on to the Q&A. So over to Pib on this one, I think.
That was excellent, really, really fascinating. Does anybody have any questions they'd like to put to the team, or wanting to find out more about what you heard about? Obviously, by all means, please use the chat functionality, or raise your hand, or switch on your camera and give us a little wave, or whatever. I'd quite like to kick off with a question, if I may, because obviously Denise said that there's a team available that people can engage with, and I know that as an SDC member, the OU uses the tools that the SDC provide to communicate with fellow members. But how can people find out what sort of thing you can collaborate with the OU with? Because I think we heard a lot about a lot of things today that I wasn't aware that you could do. So do you guys have like websites or newsletters or any of those sort of things that we can find out a bit more about what sort of areas you guys are looking at? Because it seems like there's quite a lot. So how do we know what we can approach you with? I don't know who wants to.
Yeah, I'll start on this one if you want. Yeah, there is the website. It's openupuniversity.uk/research, I think it is. And if you go on there, you can have a look around at all of the things that we do. We also have some separate pages for innovation and enterprise, and I can forward those on after this meeting. And they give you a good idea of the kind of opportunities that we've worked with people in the past, the different funding streams that we might have, and some of the opportunities that are currently there. I think this is a problem a lot of people have with accessing universities, understanding what capabilities are there. And I think if you do want something, the best thing to do is just to drop us an email, because then we can talk to you, try and understand what your challenge is or what you want to do. And then we can look around the university and actually see what opportunities are there. So I think the website's there and it's great. But I think just picking up a phone, dropping us an email and talking to us, I think that's the best way to actually try and understand what we can do for you.
Excellent, thank you very much. I noticed that Denise has just put the website address in the chat, so obviously people can access it there. Excellent stuff. Does anybody else have any particular queries or anything that they would like to ask the team? As we have them all in the room together, this is a great opportunity, so don't miss it.
Can I come in there?
Of course, please do.
Yeah, I was intrigued. Question really for Denise. Intrigued by your comments relating, as you call them, mini KTPs, which seems to me an excellent idea associated with something as short and sharp, particularly for a small business. Just to refresh my memory, you mentioned that there was a cost to the business of 1.5K. Are there any other obligations, though, associated with the business input appropriate to a mini KTP?
Obviously, the company will have to be committed to the project and help supervise the associate. Details of the application and how it will actually look are still being devised by Innovate UK, but I believe and understand that it should be announced sort of July time. So if you're interested, Bernard, I can send you the details as soon as they come out. But it's a low barrier to entry, 1.5K. You get access to academics, you learn about that specific problem that you're investigating, but also the wider resources that the OU can offer. So it's a great introduction.
Okay, thanks for that.
What we'll do as well with the follow-up to this webinar, we'll send out the video recording and slides, but also the contact details of the team at the OU. So you'll have all the details to allow you to follow up as well. Yeah, please make use of that. Right, Igor and Julia are putting some stuff in the chat as well. There's a link there to find out more about electron microscopy. Oh, that's complicated to say. Facilities. So there's a specific link there. Yeah, Julia makes a good point that obviously the SEC website is a good source as well, because as a member, the OU do post stories on our website as well. Did anybody else want to come in with anything? We still have a little bit of time left. Any questions?
I've just seen on the chat from Teresa. Yeah, I'm aware of the Actis project. So yeah, it'd be great to have a chat if there's still funding available. We did a few events as part of this project over the last few years, so it'd be interesting to see where we can take it forward. So yeah, I can put my email in the chat if you just drop me a line.
Excellent. Denise, you wanted to come in with something?
Yes, I just noticed in the chat that Khadija put something in about, hello, can you hear me?
Mm-hmm.
Yeah, sorry. I just meant, I noticed in the chat that Khadija's put in something about improving testing and new product development and manufacturing event that is taking place next week. And I wondered if she'd like to talk to people about it.
Hi, everyone. Thank you very much for giving me the opportunity. It's an event we are doing a research on because we are entering in a digital transformation and lots of changes going on due to new technology introduction to meet sustainability issue and net zero targets. So there are lots of changes going on how industries design, develop and test their product and they do manufacture. So the traditional way of testing might have changed. And also the question is, when we moving towards digital manufacturing, what's the role, how the role of physical testing is changing? So is it still the same, or is it we trying to reduce how the virtual testing is helping the physical testing? So it has to be interplay between virtual and physical testing. So in this workshop, what's really trying to kind of gather industries and academic participants to exchange our ideas, share our challenges, and to actually move forward and how do we tackle this challenge and issues. So I'll be looking forward if any of you can attend the workshop and want to share your knowledge, ideas, challenges, and learn from each other. Thank you very much.
Excellent, thank you. Anything else from anybody? Teresa, are you waving?
Oh, it's all right. All my tools just froze when Jason was talking there. So sorry about that. Yes, as he asked about that, yes, Actis still has money. It still has money till June 2023. So any small companies that sit in the region who want to work with the Open University, there are on health, well-being, any of those kinds of areas, anything we can shove into that area. We're very good at making our grants sort of be quite left field, but still have that health and well-being aspect. So anything at all that we can write around that theme for what you're building or doing, then yes, that money can be used to pay for support through the Open University as well, with the 30% intervention on that. So obviously it's something you need to do already, but if you're considering working with them, do have a think about having a chat with us as well to see if there's some way we can give you that 30%, because we really, really want to see the money spent.
Excellent, very worthwhile to check that out, especially if there's funding available. So thank you very much, Teresa. I just see a comment in the chat on some contact details to find out more about the diffusion bonding. What we'll do, we'll make sure that with the follow-up email that will include everybody's contact details and also the website links, because I know that a number of links have been posted in the chat. So I'm sure that Julia and Denise and the team can provide us with all the various links and email addresses, and then we'll make sure that we include them in the follow-up email. So you will have the details to follow up with the people as and when you can. Thumbs up. So I take it that you're happy with that, which is good. So that's great. Is there anybody else that wants to say anything or comment, or are we all keen to go to lunch? Igor has just posted something as well. Start work with you. You might want to talk to facilities directly to find out what can be done, and then we can talk to research and enterprise team to find out what scheme can be used for a partnership. Yes, I think that's something that was mentioned, that it seems to be quite a comprehensive suite available in terms of not only the work that can be done, but also how to apply for funding and where you can go to help with various things. which I'm sure Denise can talk more about, but it's definitely worthwhile reaching out, and I'm sure there's a lot of support available to help you make the most of that. Denise, am I right in saying that?
Yes, you certainly are. And, you know, at that particular time, we will find what is the most appropriate for your particular situation and need.
And do you also sit with like bid writing for grants and all that sort of stuff as and when appropriate? Is that something that you can do as well, or?
We can support you in doing this, especially if it's the first time that you've put in a grant. Our academics are very used to putting in research grants, but sometimes, particularly if it's an Innovate UK grant, which looks at it from a business point of view and perspective and has to be business led, then really we're looking at the company to lead that with academic support. But we can certainly help and advise.
Yeah, I mean, obviously you're not going to do all the work for them, which I think is understood, but I'm sure that any support is appreciated, especially as you say, if it's a first time
yeah.
hire. So
yeah, we're very good at giving you the right tips and, you know, how to sort of cut it down and make it the story sound credible, because they want to know, you know, why it is you want to do it, what the aims and objectives are, and what you're going to get out of it, what the economic, social and environmental benefits, and how you see this particular innovation or technology that you're getting from academia transforming your organization in the next 3 to 5 years.
Excellent stuff. Very, very good. Anything else from anybody while we still have 1 or 2 minutes left, or shall we leave it there? Are we all keen to go to lunch? Because we can do that. That's how we leave it. If there's nothing else from anybody, then I'd like to leave it there. Obviously, thank you very much to the OU for putting this together. Also, all the various speakers, really fascinating. I certainly learned a lot of stuff that I wasn't aware that you particularly do. As I said, we will do the follow-up to make sure that you have all the relevant details and get in touch with them. I'd also like to thank our supporter, Hexagon. Again, please check out hexagonmi.com for how they can assist with your projects as well. But we're really grateful for their support. And yeah, please do get in touch with us if there's other webinars, because this is part of a whole series that we as the STC are doing. So if there's any particular other subjects that you want to know more about, then please always feel free to get in touch. Also, please check out our YouTube channel, where we have the recordings of all the previous webinars as well. There's a huge variety of subjects in there. So by all means, please have a look. If you go to YouTube and search Silverstone Technology Cluster, then I'm sure you'll find us. And of course, there's more information available on silverstone-technologycluster.com. So do please check it out, and always get in touch with us if there's anything that we can do to help. So with that, I think we'll bring it to a close. But once again, thank you very much to the OU. Very comprehensive, very good. Thank you very much, Julia and Denise and all the rest of the team for all the efforts. And yeah, we'll look forward to seeing you on the next one. And for those of you watching at home, I hope you enjoyed the session, and please like, share and subscribe, I think, as they always say. Something to do with algorithms. So have a go with that, please. So thank you very much, and goodbye.